Basically, lots of different types of fuses. In your home, you might have some of these circuit breakers. So if there's too high a current flowing through this, it will trip out, and you can reset it with that once you've cleared the fault. Lots of different types available. For DC systems, you've got automotive blade fuses. So these ones are called blade fuses, and they fit in blade fuse holders. So pass that around. We've got the circuit breaker there. We've got these are smaller fuses, cartridge fuses, generally used for lower current devices. And we've got also these other ones. It's a thermally controlled circuit breaker. When too high a current flows through here, this will pop out and you can reset it. You've got to ensure that it's rated for the correct current and it's also rated for the right voltage. So DC is actually harder to break. It causes a bigger spark. So DC rated fuses have to be, if you're using a fuse, you have to ensure it's DC rated for the correct voltage. Otherwise you can have problems. I've seen a photovoltaic system fire because they used AC fuses where they should have used DC. You need to use them because the battery can supply really high currents. So that's the problem. You also need to monitor the system. When I got to this one system, wind turbine system, we had a voltage display which showed you from 0 to 50 volts on a 24-volt system. Now, you couldn't really read what the voltage was very well. You knew it was about 25 volts, but you didn't know exactly what it was. So I installed an expanded scale voltmeter. So this is 20 and this is 30 volts. And you can now see there's much more knowledge from the expanded scale. Generally, we use multimeters, we use some kind of visual display, the current that's flowing, and sometimes you want to know the state of charge of the battery. So if you've got a really clever system, it will tell you the state of charge of the battery. Spoken a bit about inverters. If you want to supply an AC load from a DC system, you need to convert your DC into AC. 3 different types of inverter. Start with the cheapest, slightly nasty square wave at the top. So rather than, the blue line in the middle is a sine wave, that's what you expect to have. But actually what you're supplied with is a square wave. It's not very good, it causes things to heat up, causes noise, things buzz, and it doesn't really like it. Slightly more expensive is a stepped square wave, where you get rid of a certain amount of the square wave. Sometimes called a modified sine wave, although I don't know why, because it's nothing like a sine wave. That kind of works for some things. I run most of my system on a stepped square wave inverter, but nowadays there are cheap sine wave inverters which produce a nice, beautiful sine wave, and they're the things you should use if you can get them.
Why is the stepped one better?
It gets rid of what's called the third harmonic, which, if you look at the frequencies, if you did a Fourier transform, you look at the frequency spectrum of that square wave, you would see the square wave is actually made from thousands and thousands and thousands of sine waves on top of each other. When you look at it, you get what's called the third harmonic, which in a square wave inverter is very high. Third harmonic causes heating, which is not useful. It's kind of lost energy. So the step square wave reduces the size of the third harmonic, but not much else. So that's why we use it. So here's some systems that I worked on. 500 watt wind turbine in a local circuit, and there's some beautiful photos of it. A wind-based water pumping system. So that's what they used to have to do, that kid walking water. Actually, they still have to do it because we haven't installed any plumbing system. But they don't have to pull it up from the bottom of the well. So we've really helped. This was a hybrid system. You see some solar photovoltaics here. There's a wind turbine. This was the electrical system we installed. There's a cubic wind turbine. You can see it's pretty much the same as that. So this is actually a 1 kilowatt one, so it's slightly bigger. And that was the powerhouse which had the batteries in it. So installing it. This was a photovoltaic-based water pumping system. So we had 900 watts of solar photovoltaics. Had an inverter, but an inverter with no storage. And then a pump down here. And that pumped 60 metres water up to the community. Some photovoltaic-based battery charging, so the government had installed a whole load of PV systems as part of a scheme, and most of them weren't working, it's got to admit. They had 4 solar panels. This was a little shop, and they would, for a fee, they would recharge your batteries. They were all supplied with a charge regulator and a low voltage disconnect from the government, but nearly everyone had removed that from their system because they said it recharged batteries quicker, which actually it does, but it also destroys them. Again, this is the batteries we saw before. This is the row of batteries. So the guy had a charge regulator up here. He even got it out to show me, and then he was like, "No, it's not as strong, not as strong." So good on him though. He's kept it going. This is the system that actually works. There were 3 other systems that had failed. So this guy had maintained it, and he was the guy who recharged batteries in that little place. Some problems that we experienced. That first wind turbine you saw was hit by lightning, which caused all sorts of trouble. Pretty much exploded everything. The second system we saw was attacked by insects. They like warm places. They seem to like to eat plastic. There's an ant farm in our little motor controller. Cockroaches in the things, and these are cockroaches eating the flecks to the light.
What did you do to get rid of the insects?
So what they did, they could move around in these tubes that had been installed to put the cables in. So we would fill these right up and fill you basically have to seal as much as you possibly can. And also just maintenance. So if someone's in there every day sweeping, it stops these things happening. They seem to happen just so quickly. They're absolutely incredible. Yeah. I don't know how you'd stop that one. They seem to just... There's no way you could really seal the whole light. It's difficult.
So the battery charging, you need to be really careful if you've got one battery that's high state of charge and then you start just parallel these together.
Yeah, that can cause currents to flow and also put capacitors on. Yeah. Yeah, generally if you are connecting batteries together, get them all at the same voltage or same state of charge. So we also had some short circuits. This was the inverter board in the photovoltaic water pumping system. Actually what had happened, someone had tried to put in a battery into the system, didn't really know what they were doing, they tried to put a battery on the system. And they'd blown it up. This was the first photovoltaic system we saw there, where they tried to do battery charging and they put the terminals on the wrong way around, but they hadn't used a fuse, and so it had blown the diodes in there, rectifier diodes. And this was something I travelled a long way to replace this board in the electronic load controller. I got this brand new board, came over from Indonesia. I had asked them to test it. We had no test facilities. Asked them to test it, and they said, yes, this has been tested. I got there, wired it in, and within about 15 minutes of getting to the community, it had taken me a day and a half to get there, and I wired it in, I could smell kind of burning components, and I knew within about 15 minutes that I just have to come back again, and that was the end of that trip. So what happened was this was a rectifier for the power supply for this board, and they'd installed it the wrong way around. So it was a bit annoying. Other things that happened: incorrect fusing. So this is designed to have some cartridge fuses, like you have in a typical system in this kind of place. We'd have a cartridge fuse there with a big fuse in. Now they're quite expensive, so people don't want to buy them, so they cover them in tin foil or the back of a cigarette packet and plonk them back in. Or they use this as I don't know if you can see that, it's a big thick bit of copper they've wrapped around. And that's the reason that then the diodes are blown. Other things, crazy wiring, so horrifically dangerous wiring. Incorrect cable sizing. I said about cable sizing. This was designed to take a kilowatt from these batteries, and this cable was about 4 mil. Not a good thing. I could go on about problems. Probably shouldn't. Probably should be a bit more positive. Okay, so I think at the moment I've got a bit more on generators, but I think we want to do a bit of practical stuff.